All right, this is 4.3, solving a system of equations by a new method called elimination. First, we talked about solving a system of equations by graphing, and we graphed one line, we graphed the other line, and we found the point of intersection. That's what solving a system means. You have more than one equation, and you want to find the point of intersection. So the first section we talked about graphing, and we graphed the two lines, found the point of intersection. The second section, we found solving a system of equations by a method called substitution. You basically substitute one equation into the other equation, and then solve for x or y, and get your point that way. Now we're going to talk about solving a system of equations by elimination. Now, elimination, some books call this by the adding method or the subtracting method. But what we're going to try to do is we're going to add or subtract, and we're going to end up eliminating one of the variables. Well, first, let me show you that this first example, that notice that both equations, if I ask you to solve these equations, both equations are in standard form, and both of them are lined up with one another. So in other words, look at the columns. Like literally you have the x's in a column, the y's in a column, the numbers in a column. So everything's in a column and they're all lined up. So that's something that you want to pay attention to because it's going to come in very handy when you're solving by elimination. Now, just like elementary school, when we had to add like 23 plus 12, we lined them up and then we literally added down the columns. That's really what we're going to do. We're going to just draw our line, and we're going to add each column. So 7 plus 2 is 9. Put my equal sign. Notice what happens to the y's. I have positive y and negative y. They eliminate. That's why this is called the elimination method. And then I'm going to add my x's. Well, 1x plus 2x is 3x. And then I'm going to divide both sides by 3, and then x equals 3. Now, the problem is not over. Remember, this entire section is talking about finding a system, the point of intersection. If I graph this first line, and if I graph the second line, they would cross at a certain point. Well, this is the point of intersection that we're trying to find, and what we found was x equals 3. That's the x part of the point. Now what we need to do is to find the y part of the point. So all we're going to do is substitute this 3 into one of the two equations, whichever looks easier. I think this one looks a little bit easier. So we're going to take x plus y equals 7, but x equals 3. We just found x is 3, so we're going to substitute 3 in right there. So we found y is 4. So the two things I want to point out to you, there's, the elimination method seems a lot quicker than the other methods, and it can be. The elimination method a lot of times is a lot faster if it's set up this way. Notice, everything starts off lined up, so it starts off that way. So the elimination is very quick. Now, the other thing is make sure you check your answers. I often see students just rush through this, and they make a simple mistake and they think that that's the answer. Make sure you check it. I did show you guys several different ways to check it, and we're going to go through this real quick. This is the point of intersection. I think it is. So one way to check this, if I wanted to check this, I would check this answer, 3, 4. This is the x, and this is the y, and I would substitute that in to both equations. So substitute the 3 in, substitute the 4 in, and see if that works. Yes, it works on the first equation, but it also has to work on the second equation. Make sure you always double check both equations. So you substitute 3 in for x, substitute 4 in for y, and see if it equals 2. Well, 6 minus 4, 2 equals 2. Yes, it does. So it checks on both of them. And then again, I showed you a way to triple check this on your calculator. If you solve for y equals mx plus b on both of these, you can check them on your calculator. So if I took this equation, solve for y equals mx plus b, I'm going to get y equals negative x plus 7. And so if I come over here and substitute that or type that in, And then if I substitute this one, or solve for y equals mx plus b on this one, I'm going to get y equals 2x minus 2. And if I graph this, it looks like the point is 3, 4, just by looking at it. But I also showed you guys you can do the point of intersection, second calc, choice 5 is the point of intersection. And then you just move the cursor over to where it looks like the point of intersection is and press enter 3 times. And look, it says 3, 4 is the point of intersection. So there's different ways we can check it. And just wanted to double check, make sure you understood different ways to double check, make sure your answer is correct. All right, so let's look at another one. So again, notice I'm asking you to solve the system. So I'm looking for a point. I need to find the x part of the point, and I need to find the y part of the point. So notice, first of all, they're both lined up. They're both in standard form, or at least close to standard form. The x's line up, the y's line up, the numbers line up. So I'm just going to add the columns. So literally add your x column, I get positive 1x. The y's eliminate, and I get 5. Well, x equals 5. See, that was pretty simple. And then I'm going to substitute that back in to find the y part of it. So either one of those equations, whichever looks easier, I'm just going to choose the second equation. So it says negative x plus 4y equals 3. And I think the x is 5, so I'm going to substitute 5 in. And so that's negative 5. I'm going to add 5 to both sides. Divide both sides by 4. And y equals 2. And again, so I think that's the point of intersection. One way to double check this, again, I'm not going to go through the check method on every single one of these, but make sure you understand I can plug 5 in, I can plug 2 into both equations, and it should equal 2, it should equal 3. And the other way to do it is to take both equations and graph them and find the point of intersection. So let's look at this one. Again, I'm going to notice that the x's, y's, and numbers line up, and I'm going to simply add them. Add the x column. Notice 2x minus 2x, they cross each other out. 3 plus 2 is 5y, and then add the numbers together, I'm going to get negative 5. Divide both sides by 5. And y is negative 1. Remember, I'm trying to find a point, and I just found the y part of the point. And then I just substitute that back into either one of those equations. It does not make a difference. I'm just going to take this one, and I'm going to substitute the y back in. So this is 2x minus 3. I'm going to add 3 to both sides. So x equals 2. And again, you can graph it, you can substitute them back in to double check your answer. I highly recommend that. All right, so let's look at this one. What if I gave you a problem like this? And notice, do they line up? No, that's the first thing you should notice. They do not line up. To use elimination, you need to line them up. I recommend that you put them in standard form. So you don't have to, but I recommend that you put them in standard form. So this is already in standard form, so I'm going to leave that alone. This one, I'm going to minus x from both sides. So this actually becomes negative x plus y equals 3. And then this one, again, I'm not touching this one. I'm just going to leave it alone. Now, something I want you to notice, if I started adding right now, if I add the x's and add the y's, does anything eliminate? Well, no, it does not. And so sometimes when you get to the elimination method, you're like, wait a minute, nothing eliminates. Well, what do I do? Well, I do want to eliminate them. And so what I'm going to do is I'm going to kind of think ahead. What would I need to do if I wanted to eliminate the x's or y's? It doesn't make a difference. Well, let's say I want to eliminate the x's. So if this was a 2, then the x's would eliminate. So if I wanted to cross out the x's, what I'm going to do is I'm going to multiply this whole thing by 2. Remember, what you do to one side, you have to do to the other side. So this equation now becomes negative 2x plus 2y equals 6. Don't forget to multiply him. That's a common mistake students do. Make sure you multiply everything by 2. And again, this one I'm not touching. And now if I add these equations, notice negative 2x plus 2x, these cross out, and then I can go about my business of getting the answer. And then divide by 9, and I'm going to get 16 ninths for my y. Remember, you're trying to find a point of intersection. And that's what I've gotten so far, the y part of the point. And then what I need to do to find the, that's the y part of the point. To find the x, I need to substitute that into one of the original problems, whichever looks the easiest. I think this first one looks a little bit easier. Y equals x plus 3. I'm going to substitute the y for 16 ninths. And so I'm just going to minus 3 from both sides. So 16 ninths, if you get a common denominator, let me just show it here. So 16 ninths minus the common denominator is 9. So that would be 27 to get to your answer. So you'd have negative 11 ninths to get that. All right, so let's look at one last problem. Again, you have the elimination method, and what we want to do is notice, first of all, they do line up. The x's line up, the y's line up, the numbers line up. So they're in standard form, works out good. So now what we have to do, if I added these right now, nothing eliminates. The x's don't eliminate, the y's don't eliminate. So what we need to do is to make them eliminate. So you got to kind of think ahead. Do you want, make a decision, do you want to cross out the x's or do you want to cross out the y's? And then we need to make them the same. So if I wanted to cross out the x's, then notice this is a 3. The first one's a 3, the second one's a 5. So if I made them both 15, 15x and then negative 15x, then they would cross out. So if I wanted this to become 15x and this to become negative 15x, so what do I need to multiply by? Well, you would need to multiply this by 5 and this by negative 3. Okay, and then it would eliminate the x's. So, but what if I wanted to cross out the y's? So if you wanted to cross out the y's, then you got to find a common multiple of 7 and 4, which is 28. So if I wanted to make the y's cross out, then I would multiply. If I wanted this to become 28y, like negative 28y, and this is positive 28y, then what I would want to do is multiply this. Again, I'm trying to cross out the y. So if I wanted the 7 to become a 28, I would need to multiply this whole thing by 4. And then if I wanted the negative 4 to become positive 28, I need to multiply this whole thing by negative 7. So what you have to do is make a decision on what you want to cross out. So I'm going to go back to the x's. I'm going to cross out. I'm going to multiply this by 5, and then multiply this by negative 3. So this becomes 15x, this becomes 21y, and this becomes 80. Again, make sure you multiply everything. This becomes negative 15x. This becomes positive 12y, and this becomes negative 57. And now if I added the x column, the x's eliminate. That's what you're trying to do. This becomes negative y, and this becomes 23, positive 23. It's better to do that. I needed to pause because I noticed something as soon as I got done writing it. I noticed that I had made a multiplication error. It's good to double check. 5 times 7, I put 21, and that is not the case. So let me adjust that. So this is 35. All right, and then from there, you're going to get negative 21, 23. I was about to get that. And then you're going to solve, divide both sides by negative 23, and y equals negative 1. And remember, I'm trying to find a point of intersection, so all I found was the y part of the point, and then I just need to substitute that back in to find the x, and either one equation, whichever looks the best. So I just substituted it into the second equation right there, and I substituted it into the y right here, and then solved for x equals 3. So this is the point of intersection 3, negative 1.